Hello, this is Srimati ASHWINI S, Assistant Professor of Mathematics, working at Sri Padavoda Swamiji Government First Grade College, Mudalagi, Belagavi District, Karnataka. The topic which I am going to discuss today is limits, basic definitions and problems. We all know mathematics is the queen of science. Under this, calculus plays a major role. Calculus is widely used in many different fields. For example, they are used in physics, chemistry, astronomy and so on. It is further divided into two groups, differential calculus and integral calculus. The two main scientists who are involved are Leibniz and Sir Isaac Newton. Though there are many scientists, these two scientists play a lot of role. Who are they? One is the Einstein, another one is the Leibniz. Now, this limits is widely used in the definition of continuity, differentiation and integration. Let's see the definition of few topics. After the introduction, let's see few definitions. The first definition is neighborhood of a point. Let's see what it is. Neighborhood of a point. So what we do is we will be considering three real numbers. Let C be any real number. If A and B are any two real numbers such that C is lying between A and B, that is, we say A is less than C less than B, then the open interval A comma B is called neighborhood of a point C. So basically what we are remembering here is A comma B are any two real numbers. We consider a C to be a point which is lying in between A and B. Now let me consider this particular figure. You know, this is a straight line. So these are open interval. The starting point is A, the end point is B. On this particular straight line, we can consider a point C anywhere on this particular line. A neighborhood of C is denoted by n of C. Its length is given by B minus A. The next definition which we are going to learn is symmetric neighborhood of C. So here what we do is we consider the same three real numbers. Here C will be the midpoint of A comma B. That is, in the given particular number line, A and B are taken as the initial and the final point. The point C will be exactly in between A and B. Then your open interval A comma B is called symmetric neighborhood of C. So far we have seen two definitions. First one is neighborhood of a point C and the second one is symmetric neighborhood of a point A comma B. The next definition would be epsilon neighborhood of C. If epsilon is a positive real number, then C minus epsilon comma C plus epsilon is a symmetric neighborhood of C. It can be expressed as C minus epsilon is less than X is less than C plus epsilon, or if you are writing in terms of modulus, it is mod of X minus C is less than epsilon. The next definition would be deleted neighborhood of a point. When I say deleted, you know, when we have a number of points, a particular point will be deleted. So we all know neighborhood of a point is determined or expressed by n of C. So let's consider n of C to be a neighborhood of C. The set obtained from n of C after deleting a particular point C. So what is the point we are deleting here is, we are deleting the point C, which is a real number. Then that itself is called a deleted neighborhood of C. Therefore, n of C minus C is a deleted neighborhood of C. So this can be written as C minus epsilon comma C plus epsilon minus C, that's equal to open interval of C minus epsilon comma epsilon union of C comma C plus epsilon. This is a deleted symmetric neighborhood of C. The next definition would be one-sided neighborhood. Now we have seen a neighborhood. When I say one-sided, you can have a left one or a right one. Let C be any real number. If A and B are any two real numbers such that A is less than C less than B, then let's see what is a left neighborhood as well as a right neighborhood. So the left neighborhood will be A comma C. Now C will be in the closed interval, A will be in the open interval. Now C is towards the right hand side, it is known as left neighborhood of C. Similarly, when I consider the right neighborhood of C, C will be in the right side. So C comma B is called a right neighborhood of C. Now let us see what is deleted left and right neighborhood of C. Now when I say A comma C, C is towards the right, so it is known as the left deleted neighborhood of C. And now if C is in the left hand side, we have C comma B in the left in the open interval, so it is known as right neighborhood of C. So the next one which we are going to study would be limit of a function. Now before going to the exact definition of a limit, we will be studying what is a left hand limit and what is a right hand limit. Now first of all, let us see what is a left-handed limit. A function f is said to have a left-handed limit L as x approaches C if and only if epsilon greater than 0, however small, there exists a positive number delta, and you know this delta will be depending upon epsilon, such that if I have to write it in terms of modulus, the value would be modulus of f of x minus L less than epsilon. Now since it is left-handed, it will have C minus epsilon delta is less than x is less than C. If you have to write it in symbols, since it is towards the left hand side, we will be denoting it as limit x tends to C, f of x is equal to L. This was left-handed limit. The next definition would be right-handed limit. In the same way, this will be approaching the value from the right side, so it will be C plus. Now let's see what the definition is. A function f is said to have a right-handed limit as x approaches C if and only if given epsilon greater than 0, however small. Again, there exists a positive real number delta which depends on epsilon, such that in terms of modulus it will be mod f of x minus L is less than epsilon for C less than x less than. Now since it is towards the right side, it will have C plus epsilon. Now in symbols we have limit x tends to C plus f of x is equal to L. Next definition would be limit. Now this limit will hold when we have both left hand side and right hand side. In general, we say it is limit as x approaches C if and only if epsilon greater than 0, however small, there exists a positive real number delta, such that modulus of f of x minus L is less than epsilon. Now let's see a particular image. This image has limit x tends to A, f of x is equal to L. Now f of x is a function and limit x tends to A is how it is approaching, and the value of L is the value of y which is just getting into. Now let's consider an example. So let me consider a function f of x is equal to x square minus 1 divided by x minus 1. Here x is not equal to 1. When I put x is equal to 1, you know the numerator and the denominator value becomes 0. So let's see how to solve this particular problem. When we look into the problem, we know the numerator is of the form a square minus b square, which is nothing but a minus b into a plus b. So x square minus 1 is written as x plus 1 into x minus 1. So the given problem reduces to limit x tends to 1 of x minus 1 into x plus 1 divided by x minus 1. X minus 1 and x minus 1 gets cancelled. Therefore limit x tends to 1 of x plus 1 is equal to 2. So the illustration which says here is, though it is not defined that x is equal to 2, the limit becomes 2 as x tends to 1. Hence we have finished all the definitions. Now we will go to the problem. Let's solve the problems on limits. The first problem is evaluate limit x tends to 2 x cube minus 8 divided by x square minus 4. You know, as soon as a problem is given, what we are supposed to do is we will be putting the value as x is equal to 2. When we do that, the problem reduces to 0 by 0 form, hence there is no solution. So the method by which we are going to use is, we are going to simplify this problem so that if there are any common terms, that will get cancelled. Now the numerator is of the form x cube minus 8, which can be written as x cube minus 2 cube, and the denominator as x square minus 2 square. Now let's see how to solve this particular problem. So what we are doing is, we will be using the formula a cube minus b cube, and we all know a cube minus b cube is a minus b into a square plus ab plus b square. This was way back studied in high school. The next formula which we are again going to use is a square minus b square is equal to a minus b into a plus b. That is, a cube minus b cube formula will be used in the numerator, and a square minus b square formula will be used for the denominator. So when I do that, the simplified part in the numerator becomes x minus 2 into x square plus 2x plus 4. That is, we substitute a is equal to x and b is equal to 2. In the denominator, a is equal to x and b is equal to 2. So later on, after this, the next step is x minus 2 gets cancelled in the numerator and denominator. We are left with limit x tends to 2, x square plus 2x plus 4 divided by x plus 2. Now 0 by 0 form is transformed to a form where we will not get 0 as the answer. Now we substitute x is equal to 2 in both numerator and denominator. When we do that, we get 12 by 4, which is equal to 3. So the answer for this particular problem is equal to 3. Now let's see our next problem. The next problem is, evaluate limit h tends to 0, 1 by h into 1 by x plus h minus 1 by x. Now here what we have to do is, we will be taking the LCM. So when I take the LCM, it is x into x plus h. We will cross multiply your terms. We get x minus of x plus h. On simplification, it becomes x minus h. We know x and x gets cancelled. After that, you have limit h tends to 0, 1 by h into minus h divided by x into x plus h. When we look into this term, you know we have h in the numerator as well as in the denominator. So both of them get cancelled. So the next step is, we will be getting limit h tends to 0, minus 1 divided by x into x plus h. So the next step what we are supposed to do is, wherever we have h values, we will be putting it as 0. When we do that, we get minus 1 by x into x plus 0, which is equal to minus 1 by x square. Hence, the solution of this particular problem is minus 1 divided by x square. Now let us see our next problem. The next problem is, evaluate limit x tends to 0, root of 1 plus x minus root of 1 minus x divided by x. Now when you look into this problem, you may feel it is very difficult, but nothing is difficult in maths, right? As the saying says, every problem has a solution. When I put x is equal to 0, again numerator becomes 0, denominator also becomes 0. We get 0 by 0 form. So let's think of a particular method by which we can solve this problem. Now you know we have root in the numerator. Now this concept is something which is not new, which most of you all, in fact every one of you have studied somewhere in your high school, known as rationalizing your numerator and denominator by its conjugate term. That is, if you have minus in the numerator, you will multiply and divide it by its conjugate, that is plus sign. If you have a plus b, then you will be rationalizing it as a minus b. So let's see what happens here. See, this is what we have done. Numerator, we have root of 1 plus x minus root of 1 minus x. We have to rationalize this numerator term. So we will be taking the conjugate of this particular term, which would become root of 1 plus x plus root of 1 minus x, isn't it? So what we have to do is, we have to multiply and divide by its conjugate, that is root of 1 plus x plus root of 1 minus x. When we do this, our numerator is of the form a minus b into a plus b. We all know a minus b into a plus b is what? A square minus b square. Here the value of a is root of 1 plus x and the value of b is root of 1 minus x. So when I say a square, root of 1 plus x whole square, square and root gets cancelled. Similar way, root of 1 minus x whole square will be there, out of which square and root gets cancelled. After cancellation, the term which we are left is limit x tends to 0, 1 plus x minus of 1 minus x divided by, the denominator part remains the same, so it is x into root of 1 plus x plus root of 1 minus x. So on simplification we get 2x divided by x of this, so x and x gets cancelled. So the simplified version becomes limit x tends to 0, 2 divided by root of 1 plus x plus root of 1 minus x. Now we have simplified the given root of the problem to the simplified version form. Now here what we are supposed to do is we will substitute x is equal to 0, that is limit x tends to 0. When we do that, numerator becomes 2. The denominator we will have 1 plus 0 plus 1 minus 0, which is equal to 1 plus 1, that's equal to 2, and 2 by 2 will be equal to 1. So the problem looked very complicated, but after solving we have got it as 1. So this is the beauty of mathematics, wherein the problem looks very difficult, but as and when you follow the steps, the problem becomes very easy and the solution becomes still more easy. So let's see our next problem. So the next problem is evaluate limit x tends to 0 sine 2x divided by x. Again, when I substitute x is equal to 0, you know it is of the form 0 by 0. So let's see how do we solve this particular problem. So most of you all know, we have studied this in your PUC as well as in your 10th standard. What is that result? The result is limit x tends to 0, sine x by x is equal to 1. So we will be using this particular result to solve the given problem. So I am going to consider the given problem as I is equal to limit x tends to 0 sine 2x divided by x. The main difference here is in the numerator we have 2x and in the denominator we have just x. Now to use the standard result, I should have the same value as we have it in the numerator, that is 2x. But when I look into the denominator, 2 is missing. So what we will do is, we will multiply and divide by 2 on RHS so that the given term reduces to the standard form. So on multiplying and dividing by 2 on RHS, we will be getting limit x tends to 0 sine 2x divided by, since I am dividing it, it is 2x into, I have to multiply it by 2, so it becomes 2. And when I look into this, 2 is a constant, so it remains as it is. Now this is of the form limit x tends to 0 sine x by x, which becomes 1. Hence we get 1 into 2 is equal to 2. Therefore the value of limit x tends to 0 sine 2x by x becomes equal to 2. So now let's see the next problem. Limit x tends to 2 x raised to 5 minus 32 divided by x cube minus 8. Now let me take the given problem as I. Now again here what we will do is, we will be using a standard result which was again studied in PUC. So this is limit x tends to a, x raised to n minus a raised to n divided by x minus a will become n into a raised to n minus 1. So the given problem will be simplified in such a way that we will be using this standard result. Now your numerator is x cube minus 32. We all know 32 is nothing but 2 raised to 5. So 32 is written as 2 raised to 5 divided by x cube minus 2 cube. Now 8 is written as 2 cube. Now next what we do is we divide numerator and denominator of RHS by x minus 2. So when I do that, I get it as limit x tends to 2, x raised to 5 minus 2 raised to 5 divided by x minus 2, the whole thing divided by x cube minus 2 cube divided by x minus 2. Now when I look into this, our numerator is also of the standard form, denominator is also of the standard form. So here in the numerator, you know n is equal to 5 and a is equal to 2. And in the denominator, n is equal to 3, a is equal to 3. So I am going to substitute the formula as n into a raised to n minus 1. So for the numerator part, it is going to be 5 into 2 raised to 5 minus 1. You know it is 5 into 2 raised to 4 divided by, here n is equal to 3 and a is equal to 3. So we have 3 into 2 cube minus 1, which is 2 square, 3 into 2 square. Now 2 power 4 is 16. So 5 into 16 is 80. 2 square is 4. 4 into 3 is 12. And 80 by 12 can be further written as 20 divided by 3. So the problem's final solution becomes 20 divided by 3. Okay. Now let's see another problem wherein a trigonometry function is involved. The problem is limit x tends to 0, 1 minus cos x divided by sine square x. We all know cos 0 is 1 and sine 0 is 0. Now again when I put the value as x is equal to 0 in the given problem, the entire problem reduces to 0 by 0 form. So hence we are supposed to simplify this given problem. So we all know cos square theta plus sine square theta is equal to 1. This is the first trigonometric identity which everybody knows, right? So from this what we will do is we will find out what is sine square x. So you know sine square x is 1 minus cos square x, which we will substitute it in the denominator. Hence we get limit x tends to 0, 1 minus cos x divided by 1 minus cos square x. Now when you look into the denominator, this looks a simplified form, isn't it? Now 1 minus cos square x is nothing but 1 minus cos x into 1 plus cos x. What have we done here? We have not done anything which is very difficult here. This is of the form a square minus b square, and everybody know a square minus b square is a minus b into a plus b. So here a is equal to 1, b is equal to cos x. When I substitute it in the formula, it becomes 1 minus cos x into 1 plus cos x. So after substituting this, you know 1 minus cos x is there in the numerator also, in the denominator also. After cancellation, we will be reducing the problem to limit x tends to 0, 1 divided by 1 plus cos x. Now let's apply the limit. So I put x is equal to 0. We get 1 divided by 1 plus cos 0. Cos 0 is 1. So you have 1 divided by 1 plus 1, which is equal to 1 divided by 2. Hence, limit x tends to 0, 1 minus cos x divided by sine square x is equal to 1 by 2. And these are the few exercise problems which you all can try it, which would be more easier for you all to solve. Now when you look into the first problem, you know it is of the a square minus b square form. This on simplification will give us the answer. Now when I look into the second problem, the hint which I can give you is, since it's as a root term, we have to rationalize it and then solve. When it comes to the third problem, I just have sine 2x by sine 5x. I can reduce this to limit x tends to 0, sine x by x form. You just have to look and think what you're supposed to do it. And the fourth problem is also same. So when you concentrate it, you will be able to solve the problem. So the references which I've used for these problems are from the books Differential Calculus by N.B. Bali, a textbook of mathematics by G.K. Ranganath, and there were few images taken from the website which comes under callworkshop.com. And thank you so much for giving me an opportunity for solving the problems on limits. Hope you all have understood this.